Now let's start part 3, which is difficulty level of 2. So it's a little bit more intensive than what we've done in the past, okay? So watch very closely. Question 18. Change 0.0312 to a fraction, and you can see that 1, 2 are going to be recurring because of those points on the top. So 1 and 2 are the only recurring decimals. So we have 0.03121212, right? So I'm going to let x be that number. Now, guys, I can see that 0 and 3 is a little bit bothering because that's not part of the recurring decimal. So other than the 0 and 3, everything else is like a pattern. So to get rid of that 0 and 3, I'm going to try to put that before the decimal point. So to do that, I must multiply by 100. Because if I multiply by 100, I should have 100x over here, and I can move 2 decimal places, or 2 places, to the right, so it becomes 3.12121212. So the zeros, we don't have to write those, so it's just 3.121212, which is what I want, because now I no longer have any number other than 1 and 2 after the decimal point. Now what I'll do is multiply by an extra 100 to the first for this one. So I have 10,000x, and then if I do that, if I multiply this by 100, the point will go 1, 2 places to the right again. So I'll have 312.12121212. And hopefully, guys, by now you should know why I multiplied by 100 and not 10 or not 1,000. You should know why, because there's 2 numbers recurring. So for the numbers after the decimal point to remain as 121212, I must multiply by 2 decimal places of 10, so 100. Okay, so hope that makes sense. Hope you know why I did 100. So now you can see that after the decimal point, they're all 1, 2, 1, 2, 1, 2. It's the same. So if I subtract it, if I had to do 2 minus 1, equation 2 minus equation 1, I know that those numbers will immediately eliminate, cancel out. So I'll do that. So I'll have 10,000x minus 100x, and then I'll have this number minus this number. So I know that after decimal point it's exactly the same, so that will all cancel out like that. Okay, so that minus that is 9,900x, and 312 minus 3 is 309. Okay, so now it's very neat and clean, so I can find that x is 309 divided by that 9,900. Okay, and just simplify further, I think you can divide top and bottom by 3, and then you should get 103 over 3,300. And that's it. Okay, I don't think we can go any further, so that's your final answer. So make sure you simplify further if you can, but that's the simplest form here. Okay, and again, guys, make sure you always, if you do have the time, but it will only take a few seconds, so put that into your calculator and just check that it's going to look exactly the same as, well, basically this. Okay, if it's not, that means you've done something wrong, so it gives you an opportunity to try again. So always check your answer for these questions, okay? Question 19 says find the integers a and b such that this cubed is a plus b root 2. Now again, guys, make sure you don't try to solve the equation, because you can't solve a and b just by using this equation, because there's 2 pronumerals and 1 equation. So what I want you to do when you get this kind of question is just work with one side and see what you get and compare it with this side. Okay, so use comparisons. Now, this one is cube. Guys, remember the expansions that we've done in the past? Remember how when we did a minus b cubed? What is this? Well, this is a cubed minus 3a squared b plus 3ab squared minus b cubed. Okay, hope this is familiar. If not, you must look back to the video that we've done expansions involving Pascal's triangle. If you don't know what I'm talking about, you must watch that video, because that's the crucial thing you must know to expand this out. Or if you don't like expanding using this, you can do a minus b, a minus, you can expand it out like this, and maybe do 2 at a time, but that takes time and that's the long way. So I don't really want you to do this way. I want you to know the Pascal's triangle and how to expand it the short way. Okay, so this is what I'm going to be using to do this question. So in this case, a is 1, b is root 8. So let's try and expand just like that. So it's going to be a cubed, which is 1 cubed. So 1 cubed goes front, minus 3, so minus 3 times a squared b. A squared is 1 squared, which is just 1, and then b is root 8. So that's why the root 8 goes there, plus 3ab squared. So the 3 goes out the front. A is just 1, so I don't need to put that. B squared is root 8 squared. Okay, and finally minus the b cubed. So b cubed is root 8 cubed. Now simplify. 1 cubed is 1 here. Root 8 squared is 8. And root 8 cubed is 8 root 8. Because root 8 cubed is root 8 squared times root 8, isn't it? So root 8 squared is 8. And therefore the root 8 follows. Okay. Now let's gather our like terms. I can say that 3 times 8 is 24. So 24 plus 1 is 25. And minus 3, these are like terms, aren't they? Because they end in root 8. So negative 3 minus 8 is negative 11 root 8. Okay, so take a look. And it almost looks similar to that one, but the only difference is that this is root 2, but this is root 8. We know that root 8, we can say that that's root 4 times 2, right? And we know that 4 is 2 squared. So root 4 is 2, so the 2 can go out. 2 can pop out to the front. So we have 2, and then only the root 2 remains. Okay, only the 2 remains inside the root. So we can have that. We can just simplify. 11 times 2 is 22. Now you can compare this with this. A is a number in front, so I can say that A is going to be 25, and B will be the number in front of root 2, so it's going to be negative 22. Okay, so take a look. A is the first number, 25, and make sure you don't say B is just 22. It's negative 22. Because this is a positive, B must be negative 22 to make this one, okay, because the whole number is B. Alright, so that's what I have there. Does that make sense? So make sure you know this expansion as well, guys. Alright, that was question 19. Question 20. Expand and simplify. Very simple, just a bit of algebra, guys. Just spend some time doing that. I would, if you really don't know, you can follow, but I would recommend you to try it by yourself and then just check the answer with me. So I'll do that. 2a minus 5 squared is 2a squared, which is 4a squared, minus 2 times 2a times 5. So minus 2 times 2a, so minus 2 times 2 times 5 is 20. And then the a just goes back, plus b squared, which is the 5 squared. So 5 squared is 25. And this one, similar thing, but everything should be positive. So it's actually how they're the same, but only difference is that this sign is positive. Okay, guys, if you don't know what I did there, make sure you know that a plus b squared is a squared plus 2ab plus b squared. Or if a is minus b squared is a squared minus 2ab plus b squared. That's simply all I use, so I won't go through it again. Alright, so in this case, a is 2a and b is 5. And then these two are pretty much the same, except the only difference is the sign. So you make sure you follow whatever that's appropriate. That's what I did there. Now, I did use brackets because that's a negative, and I would like to take an extra step to expand out with the negative so I don't make any silly mistakes. So this one can be just left as it is, and this side, if I expand it with the negative, I'll have negative 4a squared. Negative positive is negative, negative positive is negative as well. So these signs both change to negative. Okay? And then let's gather the like terms. Now 4a squared and minus 4a squared, they will cancel out. Negative 20a minus 20a, that will be minus 40a. But see how the 25 plus 25 minus 25, that will cancel out. So the only solution left is negative 20a minus 20a, which I told you it's negative 40a. That's the only thing that's left. So that's the final answer. Okay, so that's a pretty simple answer compared to how big the question is, isn't it? So make sure you know this stuff, guys. This is important stuff. Make sure you use this to expand that one. Okay, that's question 20. 22. Factorize completely. Now, whenever you factorize, you should all know that we first must find the common factor. I can see that 2 is a common factor, so I'm going to take 2 out first, so that x squared plus 2x minus 15 is left inside the brackets. And it's a quadratic inside the brackets, so let's use some quadratic factorization. Now 15 is 3 times 5, and to make 2, I have to do positive 5 minus 3, don't I? So that's how I factorize that one. And that's it, with the 2 at the front. Okay, so remember our quadratic factorization. 23. Okay, in order to simplify this fraction, and whenever you see fractions and you see quadratics, I always want you to factorize, okay? Factorizing will always help you simplify. So, let's simplify each and one of them, each top and numerator and denominator individually. Now I can see that the numerator has a common factor of 3. Okay, 3 is a common factor. So I'm going to factorize this by 3 first, so I have 2x squared plus x and minus 6 left inside the brackets because I divide everything by 3. And then this one, I factorize like this just using our quadratic factorization skills. Or if you like, I'll do it for you just using the cross method. For the bottom part, draw a cross. On your left, you consider the factors of 4x squared. It's definitely going to be x times x to get x squared, and 4 is 2 times 2. Or you could have used 4 and 1, but I'll just start with this, and if that doesn't work, I try another one. Now the factors of 3 are just 1 and 3, so I'll put 3 there and 1 there, and you should all know that if that doesn't work out, you can swap and try again. Now, but that, obviously, you don't need to swap because they're both 2x, but if you did 4x and 1x, then you would have to swap if it didn't work out. Now anyway, 2x times 1, you multiply crossways, right? 2x times 3, 6x, and we need to make negative 8x. To get negative 8, we need to do minus 6x minus 2x. So that minus goes there, that minus goes there. And you should all know that negative 3 times negative 1 is positive 3, so I think we've got the right one. So it's this times this. So we get that as the denominator. Okay, just showing how you use the cross method. But we've done a lot of these in quadratic factorization. Okay, so now I think we can go further. Can we factorize this quadratic? I think we can, again using our cross method. So again, I'll try some cross method factorization. So let me try that on the board. If you already know how to do this, you can skip a little bit and just check the answer, okay? So always feel free to do that. Now this one, it's going to be 2x times x to make 2x squared, right? And 6, we can have 1 and 6, 3 and 2. So I'll try 3 and 2 first, okay? So I'll try 3 there and 2 there. And if that doesn't work, I'll swap it around and try again. 2x times 2 is 4x. X times 3 is 3x. And then we need to have positive x with these two numbers. How do I make positive x with those? Well, I think negative 3 plus 4 will make positive 1. So negative 3x plus 4x will make positive x. So that will go there, and that plus will go there. And I know that negative 3 times positive 2 is negative 6, so I think I've got the right combination. So it's going to be this times this. So it's 2x minus 3 times x plus 2. So I factorized it further. So always factorize as much as possible and use enough steps to do that. Now have a look at this, guys. Can we cancel anything out? I think this and this is common, so I can cancel that out. But there's nothing else in common, so that's pretty much it. So we have 3x plus 2 on the numerator and 2x minus 1 left on the denominator. And that's it, we can't go any further than that. So that's the answer. So make sure you know how to do the cross method. Okay, so that was question 23. 24, okay, now we've got more fractions, great. So again, I'm going to factorize like I said in the previous question. I always want to factorize when I see quadratics and whenever I see fractions, just to help me simplify. So let's go for it, guys. There's 4 quadratics that we have to factorize. So if you can do this question again, just guys, do it on your own, pause for a moment and just check the answer, okay? Alright, that's what I've got. So a squared minus a minus 6. 6 is a multiple of 3 and 2. So I did a minus 3, a plus 2, because I know that minus 3 plus 2 is minus 1. And then the denominator, 15, is 5 times 3. And I know that 5, positive 5, minus 3 makes positive 2. So that's how I got that. And then this one, 35, is 7 times 5, and I know that 7 plus 5 is 12. So that's why I have plus 7 plus 5 here. And here, 14 is 2 times 7, and I know that 2 plus 7 is 9. So that's why I did plus 2 plus 7 on here. Okay, just go step by step, be very careful. Okay, just do it individually. And because it's multiplication, I can cancel crossways this way, but you can't go sideways, of course. So see if you can cancel anything. I think I can cancel the a plus 2 and a plus 2, a plus 7 and a plus 7, a plus 5 and a plus 5, and a minus 3 and a minus 3. Oh my goodness, we've cancelled everything, which means only 1 is left over. Okay, well, it's a pretty big question for such a small answer, isn't it? So hopefully that was a bit fun. Okay, so the answer is just 1, guys, because everything cancels out. Make sure you don't say it's 0 though. Okay, just because it cancels out, don't say it's 0, it's 1. Okay? Okay, cool, that's question 24, nice and simple. 25, alright, we're going to express this expression in the form of a plus b root 2. So again, I'm just not going to worry about this for a moment. I'm just going to expand and simplify this and then compare it with this. Okay? So let's go ahead and expand that. I know I told you how to expand the square, so let's go for it. So it's going to be root 6 squared minus 2 times root 6 times 2 root 3. So I'll just put all that there. I'll expand it in the next step. And then it's going to be plus 2 root 3 squared. So it's 2 squared, root 3 squared. I'll just write it separately. Now root 6 squared is 6. 2 times 2 is 4. Root 6 times root 3 is root 18. 2 squared is 4. Root 3 squared is just 3. Okay? Now, 4 times 3 is 12. So 12 plus 4 is, okay, well, I'll tell you, 4 times 3 is 12. So 12 plus 6 is 18. And you should also know that 18 is 9 times 2. So root 9 is 3. So that's why the 3 pops out like that. And only the 2 is left inside the bracket, in the square root, sorry, not bracket. So 4 times 3 is 12. And guys, have a look, compare it with this. Is it in that form? Yes, it is, because I've got the root 2 and the root 2, and I've got the 2 numbers in front. This is definitely in that form. So in this case, you could say that A is 18 and B is negative 12. Okay, make sure it's not just positive 12, it's negative 12. But you can just leave it like that because all it's asking is to write it in that form. Okay, so that concludes it. That's the answer to the question. That's 25. Now 26. Okay, very similar question, but it says if this expression is equal to this, find the value of a and b. Alright guys, just leave this alone, trying to expand and simplify this, and again do that comparison. So once you've got the solution of this one, compare it with this side. Okay, that's what I want you to do. So this expanded will be 2 squared plus 2 times 2 times root 3. So 2 times 2 times root 3 plus root 3 squared. Okay, just the expansion that we've done so many times before. So 2 squared is 4, 2 times 2 is 4, root 3 squared is 3. And then 4 plus 3 is 7. So I have 7 plus 4 root 3. Now don't think that's the end, and please don't say b is just 3, okay? This one has nothing out the front, or basically 1 out the front. But this one has 4 out the front. I don't want 4. How do I put 4 back inside the third? Well, we know that 4 is square root of 4 squared. So I can change the 4 to square root of 4 squared and then continue with the root 3. So that's how I get that whole thing inside the third. So 4 squared times 3 inside that singular third. Okay? Now, 4 squared is 16. 16 times 3 is 48. So now compare it with this side. I think you can see that these two are in the same form. So what's A and what's B? A is 7, simply the number out the front, and B is simply the number inside the square root, so B is 48, and that's it. Okay, so again, you should know how to approach these kind of questions by now. It's a very typical exam type question, so make sure you know how to do that. Always use some comparisons. So that concludes this part.